Ready to take your coding skills to the next level? Udemy is the best place to learn new programming languages and frameworks. It's an online course marketplace with thousands of web development and data science courses, all taught by expert instructors. Get started now by clicking the link below this video.
We're going to spend a lot of time in the JavaScript console. In Chrome, it's in this little settings panel under Tools and JavaScript console. And there's a keyboard shortcut for it that you can use in the future. But just open it up. And in here we can type JavaScript code, and then the JavaScript code runs right away. And it gives us the output. So we can type console, make this bigger, console.log, all lowercase, begin parentheses, quotes, hello world, end quote, end parentheses, and then a semicolon at the end of the line. Every statement in JavaScript should have a semicolon at the end of it. So if I hit enter here, it prints out hello world to the console. It logs it to the console. That's why it's called console.log. So this is actually a function called log that's on this object called console. And we'll create our own objects and functions so you can see how things are put together. So I'm going to go through all of the JavaScript language in little tiny programs, just so you get a sense of what programming is all about. So one of the things that's in pretty much every programming language is variables. And to make a variable in JavaScript, we use var, V-A-R. So type var space x equals 5, semicolon. And then if we type x, we get the value 5. And if we type x again, we get 5 again. And if we just type x equals 7, and then get x, now x is changed to 7. Variables could be named anything. You could say var y equals 50, and you get 50 back. Numbers are just one kind of thing that variables can contain. They can contain strings also. So maybe you want a variable called name equals, in quotes, let's say Fred. And the name is now Fred. And with JavaScript, you can also use single quotes to define strings. They don't need to be double quotes. So this does the same thing as the previous thing. There's also true and false as primitives in the language. So you can say var x equals true. And then x is true. And these values of true and false are called booleans. They can be used with the if statement that only executes code inside of the if block if that thing is true. Type this with me. If parentheses x, end parentheses, and then a curly brace, begin curly brace. It's next to the P on the keyboard. So the stuff that's inside the curly braces will get executed if x is true. So inside these curly braces, you need a beginning and an end curly brace. You can type console.log hello, or whatever. So if I execute this line of code, it prints out hello. But now if I set x to be false, x equals false, and then you can use the up arrow to go back to the previous command that you entered, previous code that you entered. So now if I run the same code, if x then console.log hello, nothing happens because x is false. So this is called conditional execution. This is the if statement. Let's make a variable a. So var a equals true, and var b equals false. So a is true, b is false. We can type a ampersand ampersand b. So this means a and b. If a and b are both true, then this operator will return true. So a is true, b is false. So if we set b to be false, true, if we set b to be true, now they're both true. And now if we execute a and b, we get true. Another operator is or. It's two pipe symbols. And the pipe is above the slash on the keyboard. So a or b Right now they're both true, so this is going to return to us true. So if we set B to be false, A is still true. So now if we type A or B, we get true because one of them is true. If either one of them is true, then the OR operator returns true. So if we set A equal to false, so now A and B are both false, and then we do A or B, we get false back. Let's say we have two numbers, x and y. So let's make var x equals 5, and then var y equals 10. We have some operators that work on numbers but give us booleans as values, like less than. X is less than y. We can type that less than character, and this will give us true. And if we say y is less than x, it'll be false because 10 is not less than 5. There's also the equals variant. So this is strictly less than, but then there's less than or equal to, which is less than and then the equals symbol, less than or equal to. And you could do the same thing with greater than or equal to. So for example, if we say 5 is less than 5, it's false, but 5 less than or equal to 5 is true. You don't need the spaces. People usually put the spaces in because it makes the code more readable, but you don't strictly need them. Yeah, and you could put 5 spaces too, you know. It doesn't matter. In JavaScript, white space, so white space means, you know, spaces, new lines, tabs. White space doesn't matter in JavaScript that much. I mean, there's some certain cases where it does, but like in other languages like Python, white space matters a lot, but not for JavaScript. There's also equals. 5 equals 5. This tests if they're equal. So 5 equals 5 is true, and you know 5 is not equal to 6. It can't be just one equal sign because the one equal sign means assignment. Remember we used like x equals 5. That sets x to be 5. But this other line of code, x equals 5, will check whether x and 5 are the same. And x happens to be 5, so it returns true. So that's how you check if two numbers are equal. This also works for strings. So if you have hello equals hello, it'll be true. But if the other hello, if one hello is capitalized and the other one's not capitalized, they're not the same. This returns false. And so that's equality, and then there's the inverse, which is not equal to, which is exclamation point equal sign. So let's see, x is 5, y is 10. So x not equal y should give us true because they're not the same. So far we've covered primitives, which is the types of things, booleans, strings, and numbers, and operations. Next I'm going to cover objects. So objects are the one of the central things about JavaScript and programming in general. An object is a thing that maps keys to values. So let's make our first object. So var O, I'm going to call it, equals begin and end curly brace. This is an empty object. So we say var O equals begin end curly brace. O is now an object. So we type O, we get, it's an object, but it has nothing in it. So here we can use the dot. So O dot x equals 5. It's like a variable, but it's attached to this object. So we can say O dot x equals 5, and then if we just type O dot x, it gives us 5 back. And we could type O dot y is 50. And now if we type O, it tells us it's an object that has these two different properties, x and y, and it tells us their values. And you can just keep on going, adding different properties to these objects. Sometimes the property name is different depending on like when the code is run, or maybe depending on user input. So there's an alternative to the dot, which is the square brackets. So if we type O square bracket and then quote x, it'll give us the value of x. And we can also use this notation to assign it. So O at x is 6, and then if we type O dot x, we get 6 back. So The dot and the square braces with strings is just two different ways of expressing the same thing. The square bracket notation is useful when you want to plug in a variable there. So let's say like var p, I'm going to call it, equals z. So say we want to assign something to the property whose name is inside the variable p, we could say o square bracket p equals 60. And now if we type o, see, now it has another property z. So I'm just demonstrating this square bracket thing. You have to pass in a string to this. So these are objects, and objects can have properties that are strings also, like o dot first name equals Fred. Say. Now o has all these different properties, and objects can be nested. A property of one object could be another object. So let's say o dot foo. So foo and bar are often used as like variable names that just don't mean anything, just to demonstrate a concept. So we could say o dot foo equals begin end curly brace. This will create a new empty object. But by the way, with the curly braces, you can actually put the properties inside the curly braces when you create the object. So let's say foo has a property a colon 100, say. So that's how you say this object is going to have a property a that has the value 100. And if you want multiple properties, you put a comma in there, and then let's say b is 200. So if we say o.foo equals this object, we hit enter. Now if we type o, it tells us there's this object inside of there. And Chrome actually has this really nice feature where you can click this little arrow and it will tell you all the properties. It'll lay them down vertically, and you see foo is an actual object that has other properties. So now we can see this outer object has these properties, XYZ, first name, and then foo, which is another object that has yet even more properties. So this is the concept of a JavaScript object. It's a key value mapping, and the values could be anything. They could be primitives, they could be objects. They could also be arrays or functions. I'll show you now what an array is. Let's make a variable a equals begin end square bracket. This is an empty array. The square brackets means array. And so inside the square bracket, you could put values like 1, 2, 3, 5, like that. So a equals this, and now if we print out a, it tells us, okay, yeah, you've got this array. It's a list. An array is a list of things. And there are a lot of different ways we can use arrays. One thing we can do is get out a value at a particular location, a particular address within the array. So it's called an index. So the indices of an array start at 0. So a at the index 0 would be 1, and a at index 1 would be the value 2. So let's say we want to get the third thing in out of there. We want to know what the value is. That would be a square bracket 2. Because remember, the index starts at 0. So 0, 1, 2 should give us 3 back, and it does. And we can also use this square bracket notation to assign a new number. Let's say 500. So now the element at index 2 of the array a contains the value 500. So now if we type a, it says 1, 2, 500, 5. See, that 3 has been replaced by 500. And another thing we can do is add values onto the end of an array using the push function of arrays. So we can say a dot push, and then begin and end parentheses, and then a semicolon. So this is what a function call looks like, these parentheses, and inside the parentheses go the arguments to the function. So push takes one argument, which is the thing that's to be added onto the end of the array. So let's push another number, say 100. A.push 100. It gives us the new length of the array back. And if we type A, there's now a 100 at the end of it. And the opposite of push is pop. So this is the stack idea, where you push things onto the stack, and then when you can pop the top thing off of the stack. So if we were to call pop on A, we would get 100, and it would remove 100 from the end. And if we called pop again, it would give us 5 and remove 5. So let's do that. A.pop, begin end parentheses, because it's a function call, and then a semicolon. The result is 100, and if we inspect A now, the 100 is missing from the end. And if we call A.pop again, now it gives us 5, and the 5 is missing from the end of the array. So we can just pop, until it's gone, until there's nothing left. And it says undefined, and now A is empty. We've popped everything off of our array. So that's arrays in a nutshell. So I'll move on to functions. Let's write our first function. A function is a kind of value, just like primitives, arrays, and objects. So you can assign a function to a variable. So let's say var add. We're going to write a function that adds two numbers together and gives you the result back. So var add equals function, begin and end parentheses, and then right after those parentheses, begin and end curly brace. This is the general form of a function declaration, and then a semicolon after that. This function does nothing right now, but it is a function. So we wanted to add two numbers. Let's call those numbers A and B. So inside those parentheses, type A comma B, like that. And now the code that we write inside the curly braces has access to those arguments, they're called, A and B. They're much like variables, but they only exist inside of those curly braces for the function. So functions can be called, and when you call a function, you pass it these parameters that are arguments. So we're going to call this add function with two numbers, A and B, and then when you call a function, it returns a value when it's finished running. And there's a keyword for that called return. So let's type return inside the curly braces. Return A plus B, semicolon. This is a whole statement unto itself, and it does two things. It adds A and B together, and this A plus B is called an expression. And expressions also return values. So there's this expression A plus B, and then the value from that is returned from the function because we have this return keyword right here. So if we hit enter right now we have this function add. If we inspect add, it tells us it's this function. So now we can call add. So add, begin parentheses, let's add 1 plus 1. So add 1 comma 1, end parentheses, semicolon. This is calling the function add, and it returned the value 2. So it worked. So we can add like 1 and 5, we get 6. One thing about these function calls is the things inside the function call, these 1 and 5, could be expressions themselves. So you can add 1 and 1 plus 1. You can put that 1 plus 1 right in there in that argument. So now it adds all that stuff and you get 3. You can also call functions from within this space of the arguments. Like, for example, add 5 and 5. So check out what this is doing. It's going to call the function add 5 and 5, and it's going to use the value that was returned from that function call as an argument to the outer function call to add. So it's going to add 5 and 5 and get 10, and then it's going to add 10 and 1 and get 11, and it worked. This is the basic concept of a function. The one last thing that's sort of fundamental that I want to cover is loops. So loops can do something a bunch of times. So let's say we wanted to count from 1 to 10. Print out all the numbers from 1 to 10. So first of all, we can make a variable I, set that equal to 0, and then we can type console.log begin parentheses I, end parentheses, semicolon. So this will log the value of the variable I. So if we execute this, it says 0. I is 0. It only does it once. But we can do it 10 times if we want, using this construct called for loop. And it's a little bit complicated, but once you see it a bunch, it'll become sort of natural. It looks like this. For, begin parentheses, I equals 0, semicolon. So this I equals 0 is the initialization part. This thing gets executed once. Semicolon. And then I is less than 10, semicolon. So this middle expression is a check that the code uses if it should keep going or not. So every time through the loop it checks, is I less than 10? If yes, then it does the loop again, and if not, then it stops. So this check gets executed every time through the loop. And then there's one last part, I plus plus. What that really means is I equals I plus 1. And then begin and end curly braces. So for I equals 0, semicolon, I is less than 10, semicolon, I equals I plus 1, end parentheses. So that I equals I plus 1 gets executed every time the content of the loop is finished. So that adds 1 to I. So I is going to get added to, until I reaches 10. And then it's going to stop. But inside these curly braces, let's add what we had before, console.log I. When we run it, it prints out all the values that I had each time through the loop, which is 0 through 9. Because I started at 0, and it keeps going, while I is less than 10. And as soon as I is not less than 10, in other words, when I gets to 10, it stops. So if we wanted to count, 1 through 10, we would have to console.log I plus 1. And then it gives us 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is a for loop. We've covered all the elements of the language. And now we're ready to move on to graphics, to drawing things on the screen. So I want you to go to currentsoft.com/interactive graphics. Load up that page. So if you scroll down to how can we draw things on the screen? On this page, there's actually a canvas right there. See, I can select it. It's got nothing on it yet, but that's a space where we can draw things with JavaScript. If we open up the console again, type canvas. You see, this is the element on the page. It's got an ID of canvas, and that's why it's available as a variable here to us. And we can use that. We can access that from JavaScript. A canvas is like an image, a bunch of pixels that are empty. And it's got this set of functions you can call to draw things on it. And those functions are on what's called a context object. And the first thing we need to do is get that context object out of the canvas. So let's say var c equals canvas dot get context. And the C of the context is capitalized. So GET capital C context. Parentheses, quote, 2D, end quote, end parentheses, semicolon. So this will get the 2D drawing functions out of that canvas. And now we can do things like draw a rectangle. So let's type c.fill rect with a capital R. Begin end parentheses, semicolon. And the arguments, it takes 4 arguments. The X and Y position where it should start, and then the width and height of the rectangle. So let's use 0, 0 as the XY position. And by the way, 0, 0 is the upper left corner of the canvas. Unlike in math, where 0, 0 is like the bottom left corner, it's the top left. And as the Y value increases, it goes down, which is a little counterintuitive, but just so you're aware. So 0, 0 is the XY, and then width, height. Let's make it 50 and 50, a 50 by 50 pixel square on the screen. So when we run this, bam, it draws this rectangle on the screen. It draws the square. Whoa, I'm hearing people say, whoa, that's awesome. So we can do things like change the color also. Try this, c.fill style equals, quote, red. c.fill style equals red. And then if we run that command that we ran before, actually I'm going to use 40 by 40 so we can see both of them. Now it draws a red rectangle. So yeah, go over to jsbin.com. It's a nice web application that lets you write code inside of the web page. If you get a bunch of weird stuff at first, just refresh the page. It gives you like a welcome message, but you know, after that it gives you this empty HTML page. So in this page it has the basic structure that every single HTML page has. So we can pretty much ignore it. In the body, let's add a canvas element. So make it look like the other tags, you know, with the weird brackets. Canvas, and then not canvas. And then we should give the canvas an ID. So these are tags, and you can give tags attributes. So let's give it an ID attribute. So ID equals, quote, my canvas, end quote. And then after the canvas tag, inside the body, let's add a script tag. That's where our JavaScript can go. Like this, script and then not script. And then in this page, open up that console that you had open before. So Tools, JavaScript console. You have this thing. So it re-executes the code every time you type something. So I think that's why it gives us these errors. You can clear the console if you want by right-clicking. So let's just make sure the script is running. Let's type console.log hello. Okay, it works. So now you see every time you change the text, it reruns the code. So every time you edit the text, it's like it's refreshing the page and rerunning the whole thing, which is really cool, you know, especially for graphics development, because when you change a line of code, you see it change right away. You don't have to save and update the page and everything. So in here, let's grab that canvas context and start drawing on it. So here we can type var c equals, you see now it has the ID myCanvas, so we can access that variable myCanvas in the JavaScript space. You see, when the page loads, everything that has an ID is assigned to a global JavaScript variable that we can access. So c equals myCanvas dot get context 2D. And don't forget the parentheses and the semicolons and everything. And here we can type c.fillRect 0, 0, 50, 50. And now we have it on this screen. So to make the code more readable, often what people do is, instead of having numbers inside the function call, you can extract those to variables, and the variable names make it clear what the meaning of each number is. So let's do that. Let's make a var x equals 0, var y equals 0, var width equals 50, and var height equals 50. By the way, this convention of separating words with an uppercase letter is called camel case, because it's like the back of a camel, you know, goes up and down. In other programming languages, people use underscores, like Ruby, but the convention for JavaScript is to use camel case, like this. So now that we have these variables, we can get rid of these numbers in the arguments to fillRect and use the variables instead. So we c.fillRect x, comma y, comma width, comma height. And so now you can see if we change the width, like from 50 to 70, it updates right away. And in my opinion, this code is more readable because you know what each number means, as opposed to having just a list of numbers. What we did right now is called refactoring. Refactoring is changing around the code so it's more clear or more well organized, but it doesn't change the actual behavior of the code. And when you write a lot of code, you have to stop and refactor a lot, because otherwise the code just gets all messy and, you know, unreasonable, not comprehensible. So let's use some knowledge. Oh, first of all, I want to show you that this myCanvas object, we can get the width and height of the actual canvas on the page. So if we set width equals to myCanvas, and don't forget to capitalize the C, myCanvas.width and myCanvas.height. So now we can see the whole size of the canvas. So why is the canvas this particular size? Well, in the HTML, we didn't specify any size for it, so it just got this default size, which is, I don't know, like 100 by 300 or something. But we can set the size ourselves in the canvas tag. So right next to the ID equals myCanvas, you can type width equals quotes. I'll make it 300. And height equals 300 also. So now we have this canvas, we're controlling the size of it. Let me show you how we can use a for loop with these graphics. Let's say we want to draw 10 squares. But we don't want to write 10 lines of code, each line drawing one square. We can use a for loop to do that. So let's make that var I. We can just declare it. We don't need to set its value. And then, by the way, before you start typing it, you might want to disable this auto run. If you click that checkbox, it stops running it as you type. While you're typing for loops, it sometimes gets into a weird situation where it just runs the loop infinitely and it crashes the browser and you lose your work and you have to like restart the browser. So to avoid that, you can click that checkbox and then click it back on later. So for I equals 0, I is less than 10, say, semicolon, I equals I plus 1. End parentheses, and then begin and curly brace. And these curly braces can, like the ending curly brace can go to the next line. And then in here, if we type console.log I, like we did before, and then we turn on that auto run again, it prints out these numbers. See, it's printed it out. So you see how this code is indented one more space than the other ones? That's not strictly necessary, but it's a convention that people use to make the code more readable. So a level of indentation means, you know, there's something different happening in this part of the code. You know, in this case, it's running 10 times. So I is going between 0 and 10, right? Just for cleanliness sake, I'm going to make 10 into a variable. You might want to click that checkbox right now. So let's say I is less than n, and up at the top I'm going to make a variable n, var n equals 10, just so we can change it easily later and we don't need to change it a bunch of places in the code. Instead of console.log I, we type console.log I divided by n, and you can turn that checkbox back on. Now this will give us these decimal numbers that are between 0 and 0.9. What I'm imagining is we can draw these rectangles going across the screen from the top to the bottom. So now we have this number that basically goes from 0 to 1. We can use it and say x equals I divided by n. And then we can put this c.fillRect inside the for loop. We can move, just, Control X cuts that code, and then Control V pastes it. You can just move it around, move it into that loop. So right now it's just drawing 10 rectangles all on top of each other, and they're all big because the width and the height is big. So we can just change the width back to, let's make width 10, for example, and height can also be 10. So 10, 10. So now it's drawing 10 rectangles, but keep in mind these coordinates are in pixels, so they're a fraction of a pixel apart. So instead of I over n, which is a number that's basically between 0 and 1, we could say I over n plus canvas dot width. What's happening here? Some kind of error. Oh, canvas is not defined. Oh, right, it's my canvas. My canvas. Uh-oh, where is it? Oh, right, should be times, not plus. So it's adding it, not... what I wanted to do is multiply it. All right, here we go. 10 rectangles across the screen. So it's taking a number between 0 and 1, and it's basically, by multiplying it by the width of the canvas, it's like it's stretching it out to go between 0 and the width of the canvas. We can copy and paste this line and say y equals the same thing. And now we get this diagonal going down. But let's say we want these to be going up and down, but in the middle of the screen. So we can set the x to be, so we can delete I over n. It could be my canvas.width divided by 2. That gives you the center of the screen, the center of the canvas. So now we've got them going up and down. So this for loop and the variable I, we can put this in a function. Let's say var redraw equals function begin curly brace and end curly brace, and then we can indent all this stuff. And then there's a JavaScript function called setInterval, which is a function that takes as input another function and a time value, and it calls that function over and over and over again. So we can call setInterval begin end parentheses. The first argument to setInterval can be the redraw function, and the second one can be, say, 16 milliseconds. So the display updates 60 times a second, and 1 second divided by 60 is approximately 16 milliseconds. So this is we're getting into animation here. So let's make a variable called time outside the function. Var time equals 0, and let's say x equals my canvas.width over 2 plus time. So it's staying static right now because time is not changing. Time is staying at 0. But if outside of the for loop, after the for loop, we can say time equals time plus 0.1, or time plus 1, let's say. So now we see it's going across the screen. It stays there because we're not clearing the canvas. Every time we redraw, we can clear the canvas to actually do animation. It's just redrawing it on top of, drawing and drawing and drawing. It has to clear every time in order to really do animation. And the function for that is c.clearRect, camel case again, 0, 0, myCanvas.width, and myCanvas.height. So now it's clearing the background every time, and it's just updating these. So instead of plus time, we could say the sign of time. Capital M math dot sin of time. So the math is a library that's built into JavaScript, and sign is one function that's there. It gives you the sign of it. So you see now they're going back and forth. But it's kind of too fast. I'm going to say, instead of adding 1 to time, I'm going to add 0.1 to time every time. And then I'm going to multiply this sign by 20 to spread it out by 20 pixels. So now it's going back and forth. See? And if we say math.sign of time times I, whoa! I'm going to make that smaller. And instead of 20, I'll make it 30. Or I'll make this actually 200. Oh, that's too much. 100? There we go. And now we can change n to be 100 and draw 100 of these. Oh, now time's going too fast. Add another 0 there. That's it. There we go.